video because it keeps cutting off. So we are going to look at example 11, and we are compounding semi-annually, so I know it's going to be the original formula that we learned. So we know the principal is 5,000. The interest rate is 0.05. Semi-annually means twice a year, so n is 2. So that's 2t. They never tell me time because we're trying to find the time. So we're looking for t. That's new. For how long it takes to double the money. We know the money we want to end up with. We want to end up with $10,000. So the first thing I'm going to do is divide the 5,000 over. And that's going to give me 2 equals, this makes 1.025 if I remember correctly. And we have an exponential problem. How do we solve it? We have to take the logarithm. I'm going to use a common log of both sides. As long as I do it to both sides, I can do whatever I want. Where's this 2t going to go? It's going to move to the front. So log of 2 equals 2t log of 1.025. How do you solve for t? We have to divide by the 2 and by the log. So we're going to end up with log of 2 divided by 2 log 1.025, and that's going to give us t. I forgot to point out earlier, when we do this division, yes, you close that parentheses, but you also have to put the entire denominator in parentheses. Otherwise, your calculator won't know that all of that. It's going to think only the 2 is in the denominator. So you've got to divide by the whole thing, put it in parentheses. And when you do that, I had that on my calculator a second ago, you get 14.04. So it's going to take 14.04 years to double my money. Now we move to continuously. As soon as we read continuously, you should be thinking of the other formula, P times E to the RT. My principal is still 5,000. I still want to double my money. 10,000, E, interest rate is still 0.05. We're still looking for how long. So we divide by 5,000. 2 equals e to the 0.05t. Because it's a base e, what type of logarithm should we use? We should use the natural log of both sides. And that's nice because we can use a shortcut rule. And we're left with just 0.05t. So my last step is divide by 0.05. And when I do that, natural log divided by 0.05 is 13.86 years. So it is a little faster to invest in the continuous plan. So the last example is one more of these compounding problems. It says a sum of $1,000 is invested at an interest rate of 4% per year. Find the time, so we're looking for t, required for the amount to grow to 4,000 if the interest is compounded continuously. My continuously got chopped off by the copy machine, but it is continuously. So we know it's going to be this formula with the E. Our principal, we start with $1,000. E, the interest rate is 0.04. We're looking for T, and we want it to grow to $4,000. So what would we do first? We would divide by the 1,000. So we get 4 equals e to the 0.04t. Now what? We're going to take the logarithm of both sides, but because it's base e, I'm going to use the natural logarithm of both sides. So natural log 4 equals, look at that beautiful shortcut, 0.04t. What's my last step? Divide by 0.04, and you should get the natural log of 4 divided by 0.04 gives you, it is going to take 34.66 years. I don't remember if we were, yes, years. We were in years. To grow from 1,000 to 4,000. That's the last example. Let me make sure I didn't miss any. The last example for this section.